In this lesson, we're going to take a look at factoring special products. We'll start out reviewing factoring trinomials, as in the last lesson, using that AC method. Let's take a look at the second problem in your worksheet, 9x squared plus 54x plus 81. Remember, when we're factoring any polynomial, the first step is always look for a greatest common factor. So in reviewing the numbers, 9x squared, 54x, 81, do they have a common factor? They do have a common factor, and that common factor is 9. So let's factor that out first. So 9 times x squared, 9 times 6 is 54, and 9 times 9 is 81. Now, when we're using the AC method, we're no longer going to consider the original problem. We're going to look at just what's inside the parentheses and see if we can factor that further. So we've pulled out that greatest common factor of 9, and we need to identify the A, B, and C in our trinomial factor. Just like previously, if there isn't a number that shows up before the x squared, then our A is 1. The number multiplied by x is 6, and our constant is 9. And now we play the same game we did before. A times C. 1 times 9 is 9. B is 6. Remember, we're looking for factors of 9 that will add to be 6. So we can start out with number 1. 1 times 9 is 9, but 1 plus 9 is 10, so that doesn't work. And then the only other factor pair we have for 9 is 3. 3 plus 3 is 6, and it does work. I'm going to write the entire problem over here. I've noticed in my many years of teaching, when students factor out a greatest common factor, they tend to ignore it. And sometimes they'll put it on at the end, but most of the time they forget that they've ignored it, and it gets left off. So make sure if you factor out a greatest common factor, go ahead and carry it over when you're factoring the rest of the polynomial to make sure that you don't forget it. So now we take that 6x and break it apart into 3x and 3x. We'll keep the x squared and the 9 in that trinomial. And then I'm just going to have this outside 9 hang around while I factor inside the parentheses. Then we factor by grouping. I'm going to keep the 9 out front. X squared plus 3x. They have an x in common. X times x is x squared. X times 3 is 3x. Middle plus sign comes down. 3x plus 9, they have a 3 in common. 3 times x is 3x. 3 times 3 is 9. And then just as before, we have to factor that parentheses out one more time. This x plus 3 is a common factor that we will pull out. And then our leftovers, x plus 3 in their own parentheses. And we don't forget the 9 out front. This is our factored answer. But notice that x plus 3 and x plus 3, this is a repeated factor. So we can write it as x plus 3 squared. Put that 9 out front for that greatest common factor. This trinomial, x squared plus 6x plus 9, is called a perfect square trinomial. We call it a perfect square trinomial because it has two factors that are identical. So we're squaring one of the factors to end up with this trinomial. These perfect square trinomials might not always be recognizable. They do have a particular pattern to them, and we'll write that pattern down. But I just want to emphasize that you do not have to memorize the pattern or try to identify that it is a perfect square trinomial. You can always factor these trinomials just like we were doing before with the AC method. And taking a look at a similar problem, u squared minus 10u plus 25. Let's identify our coefficients. A is 1, B is negative 10, C is 25. What to notice about these perfect square trinomials is, first off, C is a perfect square. 5 times 5 is 25. In our previous problem, we had C being 9. 3 times 3 is 9. 9 is another perfect square. So this is one hint that it might be a perfect square trinomial, but a perfect square trinomial has two parts. C has to be a perfect square, and B has to be 2 times the factor of C, and B can be plus or minus 2 times that factor. And so in this case, we've got a negative. That's okay. In this case, we've got negative. That's okay. So let's try the AC method again, see if it works, and then we'll write down a brief formula to help identify if you wanted to use the identification of perfect square trinomial instead of factoring. So 1 times 25 is 25. B is negative 10. And remember, we're writing sums over here on the right, factors on the left. Start out with 1. 1 times 25 is 25. Add it together is 26. That's not going to work. But I need B to be negative. So I don't want positive numbers over here. Let's make those negative. And then the only other option we have to multiply to be 25 are negative 5s. And negative 5 plus negative 5 adds to be negative 10. And that factor pair works. Notice that our factor pair is a repeated number. That's how we know it's a perfect square trinomial. So coming over here, u squared minus 10u plus 25. We can split the minus 10u. We're going to split it into negative 5u minus 5u. And then tack on the first and the last terms. And then just like before, factoring by grouping. Group the first two, group the last two. First group has a u in common, so we'll pull that out. U times u is u squared. U times negative 5 is negative 5u. Middle sign here, bring it down. If you always bring the middle sign down in factoring by grouping, if the 4-term polynomial is factorable, this will work out to your advantage. And then we look, 5u and 25 have a 5 in common. So negative 5 times u is negative 5u. Negative 5 times negative 5 will give us positive 25. That's that sign change we need in order to get the correct product up top. And just like before, the u minus 5s are going to come out as one factor in that reverse distributive property. And then the leftover bits we put in its own parentheses. Just like before, notice it's a repeated factor, u minus 5 squared. Perfect square trinomials have a very distinct pattern in that the first term and the last term should be squared. No, I don't like using these letters, but these are the letters that match the textbook, so I will keep them here for now. Just know that this A and B are not the same A and B that we were using for the trinomial factoring. If the first and the third terms are perfect squares, and the middle term is 2 times the factors of those perfect squares, then this type of trinomial will factor as a plus b squared. Similarly, if the middle term is negative, the factors are a minus b squared. Looking at the example we did previously, x squared plus 6x plus 9, and I'm going to rewrite this as the different terms that we have. Hopefully to make it a little bit easier to see that according to our formula above, a is x and b is 3. So we have that pattern of a squared plus 2ab. They're switched, but order of multiplication doesn't matter. Plus b squared. And we saw when we factored x squared plus 6x plus 9, it factored as x plus 3 squared. Exactly like above. And again, if you recognize the pattern, you can write the identical factors of the perfect square. Next up, factoring special products. If we take a look at the problem 3x squared plus 12, we factor the 3 out. Factor that common factor of 3, we end up with 3 times x squared plus 4. This factor, x squared plus 4, is called a sum of squares. Notice x is a perfect square. Notice x is a perfect square. And 4 is a perfect square. And we've got a sum in the middle. A sum of squares is not factorable. I'm not able to split that into 2 factors like we were doing with other polynomials that had x squared in them.